video, I'd like to show you the new features in CabWriter CNC 2.0. We've enhanced what you can do when exporting to CNC. So let's take a look. As you may know, CabWriter Pro 2.0 now allows you to have some more sophisticated cabinet construction techniques that lend themselves to CNC. So if we look at this cabinet and move this away, we see that we've got some qualified tenon construction here, and we've got an inset back. So we've got grooves in addition to the holes that we used to have in CabWriter 1.0 that we supported. We've now got tongue and groove construction, qualified tenon, dado rabbet, all sorts of things. And so there's a separate video that covers how to set all that up and have it draw properly. But in this video I want to show you how you use the CNC settings so when we export the DXF we get what we need. So in another video I showed how to use the new CabWriter production documentation to export our DXFs. So we can export DXF with material name and thickness. But before we do that, we want to go to our CNC setup. So just a quick refresher. If you want your drilling method to be CNC, selective hole drilling, you want on the project tab, you want CNC selected. And that is the same as it was in CabWriter 1.0. This whole tab, CNC boring, lets us set up for our system holes, hinge plate system holes, drawer slide, shelf construction holes, connector holes, and that sort of thing. So that's all exactly the same as 1.0. What is new is the CNC Setup tab that gives us a bit of information here. So let's cover it from the bottom up here. So CNC milled faces. This is important because if you say look at a stretcher or a cabinet bottom. Let's look at the bottom first. For this bottom to get milled correctly, the milling has to come from this side, or the bottom of the bottom, in which case the top of the bottom is going to be on the CNC bed and this face is going to be up. So we have to tell CabWriter which face we want to consider up when the DXF is created. And in this case, on a bottom, we're going to use the outside face, and the same with the stretchers. We have to have this face down on the table, which means the outside face is going to be up. The sides, we typically want the inside. Same with the fixed shelf, we want the bottom of it. And the back, we need if we want to look at the back here, we need the outside of the back is where the milling is going to happen, so that has to be up. So if you export to DXF and you're not getting what you expect, this is something to double check, because you might have, this is the default here, but in certain situations your machining might occur on the other side, in which case you need to just change this to inside or outside, as the case may be. This parameter is the same as was in CabWriter 1.0, but it was on the Projects tab, and now it's on the CNC tab. So all this is saying is if a part is less than 100 square inches, put it on a separate layer on the DXF, and that's this small outside profile layer. And that's so that you can toolpath it differently and do something called onion skinning if you want, which is not cutting all the way through the material so the part doesn't break away when it gets fully cut out. Small parts might not have enough vacuum pressure to hold them down to the table if they get cut all the way through. So onion skin means just leave a very, very small amount of material when you cut through the part that you can break it away later. So this tells how big of a part you consider a small part. And anything below that will go on this small outside profile layer. Anything above that will go on the large outside profile layer. In CabWriter 1.0, these layers and then any drilling will go on a drill layer, and labels will go on the labels layer. In CabWriter 1.0, we only had those 4 layers: drill, small outside profile, large outside profile, and labels. And they had fixed names, they weren't changeable. So one of the big changes that we've done here in CabWriter 2.0 is we now have 2 new types of layers: inside profile and pocket. So pocket would be anything that mills into a part and creates a pocket. So that would be any of these grooves, dados, rabbets. This is also considered a pocket here, creating this rabbet milling in from this side, whereas the outside profile is the outside profile of the part. Inside profile would be, let's say you wanted to make a cutout in this cabinet back. I could edit this part. I could take a rectangle. We only support rectangles or squares at this point. And I could push that all the way through, and now I've got a hole in this part. And CNC 2.0 will detect any cutouts of a circular nature or a rectangular nature, and it will put that on the DXF for you, and it will put it under the inside profile layer. Pockets on pocket layers, inside profiles on inside profile layer. So now we have 6 different types of layers. And I'm going to come back to all this stuff right here and just pop up here for a sec. So we allow you to put in 3 different drill bit sizes, diameters, in either millimeters or decimal or fractional. And what's going to happen is when CabWriter detects a circular hole, it's going to look at the diameter of that hole, and if it happens to match up with one of your drill bit sizes here, like all these holes are 5 millimeter down here, they would match up with the 5 millimeter entry. That means that hole will go on the drill layer because it's obviously matching a drill. And here's the name of the drill. That's just a string. You can call it anything you want. Typically it's going to match what you call it in your tool library in your CNC software. If it matches any one of these 3, it will go on the layer. And if you have holes of different sizes, like say we had some 1/4 inch holes and some 5 millimeter holes, CabWriter would create 2 different drill layers. One with the 1/4 inch name, and the other with the 5 millimeter name. We'll get back to that here in a second. And then we have a cutting bit table. So you give the diameter of the bit you're using for outside profile and its name, inside profile and its name, and pocket in its name. Make sure you don't use slashes like this in the name. If you do so, it will, those aren't recognized. There's certain characters that aren't recognized in DXF layer names. So if you create your DXF and you try to open it and you get an error opening it up, you might want to check the names that you put in here, because they translate into the layer names, and it won't be recognized by some programs. So these diameters will also end up in the layer name, and the names of the bits will end up in there as well. So I'll show you that in a sec. I want to cover one thing about these bit diameters, particularly the one for the pocket. So if we go back here, cover this in the video where we talk about this construction technique, but if we look here, and I need to zoom out and then zoom back in. All right, so we've got a constrained pocket here, and if we made this tenon the exact same width as this pocket, remember when we're seeing this pocket, it's not going to be square, it's going to be a round bit, and it's going to have a radius on each end here. So in order to compensate for that, if we look at the length of this pocket, it's 2 inches. But if we look at the length of our tenon over here, it's 1 5/8 inches. So it's 3/8 of an inch less than the width of this pocket. That's 3/16 on this side and 3/16 on this side. And we get that number from the CNC Setup tab. The bit that's used to cut this pocket is going to be 3/8 of an inch. So it's going to leave a half of the diameter little round radius here. So what we do is CabWriter automatically takes half of that bit diameter and subtracts that much from the tenon so that it clears the little round bit that's here. So if you're wondering why this gets shortened, that's why, and that's by how much. The setting on this tab. All right, so now all this stuff here. Basically what's going on here is, here's the prefix. If you leave this blank, we would use the word drill in there. Otherwise, whatever string is in here will be used as the initial string for the layer name, and followed by any one of these parameters. So we've chosen, these are the defaults that are in there. So we're going to use diameter first, and then followed by an _D for diameter. We could put any string in there that we wanted, followed by the depth. So the diameter comes from the, in drilling's case, the match that was made on the drill table. And then the depth is all holes of the same depth will be put on one layer. So you could have quite a few drill layers. If you had different diameters and different depths within each diameter, each combination of those would go on its own layer. And you would have embedded in the layer name the diameter, the depth, and then followed by, in this case, the name. So the name of the drill bit would be in there. So let's say on the small outside profile, we're calling it small _OPL _T. And we have the diameter, and that would be the diameter of the bit that's used to make an outside profile, with _D for that, and then followed by the depth. And that's what CabWriter detects as the depth, and then _N indicates the name. So the name is this name here, which is any string you want, hopefully matches your tool library name. All this is so that you can know, basically we're embedding the information you need to create the tool path in the name of the DXF layer. And that can either come in handy because it can tell you when you have to manually do the tool pathing in your software what you need to do for that layer, or if you're lucky enough to have CAM software, for example, the BSE CNCs can take the based on the name of the layer name, the information directly out of that and skip the tool pathing altogether, and it'll know exactly how to do the cutting. And there are other programs that can do that as well. So if you have a program like that, you can modify all these labels and order of labels and order of variables to match what your software would like to see so that it could do automatic tool pathing. I use Vectrix software. I use Cut2D Pro, but it works the same in Aspire or any of their products. they can apply templates based on the layer name, and I will show you that in another video. But by having this information in the layer name, it makes it easy for me to do templates for any of the combinations of stuff that I commonly see in my construction. So if we go and I've already created the production documentation for this project, and if we go look, we're going to see a folder that was created with my DXF files in it. So I'm going to grab one of these files and open it using AutoCAD so that we can look at the DXF. And let's open this up a little bit. And a DXF file is just going to have all the parts one right after another. So if I zoom in, you can see there's a million little parts here. And let's see if we can find one that's got some rabbits. There's some tenons and pockets on it. Here's one right here. So we can see we've got holes. If we look over here, we've got two drill layers. One, we've got using 5mm diameter and a depth of 3/4 of an inch, and we're using the 5mm underscore drill. So if I turn that off, you'll see we lose some holes on there. If I turn the other drill layer off, we lose more holes. Those are the 5mm holes, but they only go to 1/2 inch deep using the same drill. If we look, our large outside perimeter is here, and we're saying large outside perimeter. The tool is a 3/8 inch bit. The depth is 3/4 of an inch, and we're using the 3-8 comp bit to do the cutting. And then we have the pockets. So the pockets are simply rectangles overlaid with the boundary of the pocket that we want to cut. So in the case of these where the tenons go into, if you recall, they're cut to the full width, but they're going to end up with a little radius in here, so we undercut the tenons. And for this groove, it goes all the way to the end, but if we stopped our bit right at the very end here, we would have a little chunk of radius still left there. So we overcut by the full diameter of the bit that's specified in our table for pockets, because this is a pocket ultimately. All these are pockets. They're on the pocket layer, and they all happen to be using the same tool, the 3/8. The depth happens to be 3/8, and this is the name of the bit. So that's what you'll see. If we look at one that's got some tongues, we'll see here that if we turn our pocket layer off, you see how it's overcutting on the ends and all the way around so that we avoid having little bits of material still there with the radius. If we stopped just within this boundary of this tongue, we would have little radius parts that weren't cut there. So you can see the pocket overcuts. And then this is probably a small part, so it's on the small outside profile layer, which again is 3/8 tool, 3/4 of an inch deep, and so on. So all the information we need to do our tool pathing is encoded in these layers. And the pockets are simply rectangles that are oversized based on the information in the bit diameter table. So that is the new CNC features. And you need to definitely play around with it and make sure the first time you do this that you double check your DXFs and make sure that things make sense the way you expected them to come out. And if not, play around with your construction method and your settings until you get what you need. All right, thank you.